we can find limits, we can look at graphs, we can make t-charts, but it's kind of annoying. The graph can be misleading, like we saw in that last problem. I know a few of you, the graph made it look like it was going to negative infinity, but we had to adjust the window to see that it really wasn't. The t-charts take a lot of time to plug in things, and even those are not foolproof. So we would like some other options. We're going to use limits all year long, so we don't want to have to make these every single time. And it turns out there are some shortcuts. So these are the limit laws, the things that we can now assume are true. So if you have the limit of two things added together, you can do individual limits. Okay, so that's like saying if I had a limit as x approach 3 of 2x plus 1. You could do the limit as x approaches 3 of 2x plus the limit as x approaches 3 of 1. Okay, so if you have things added or subtracted, that's the second rule, we can break them apart and do the limit of each individually. The third one says if you have the limit of a constant times the function, you can pull that constant out in front. So it's saying if I have the limit as x approaches 3 of 2x, I could rewrite that as 2 times the limit as x approaches 3 of x. So the coefficients can come out in front. Alright, so far these don't necessarily look like they're going to save me a lot of time. Makes me write the limit more often. But I haven't really shown you how that's beneficial yet. We can do the same policies with multiplication and division. So if you have things being multiplied, we can do each limit separately and multiply them together. Same with division, as long as the bottom isn't 0, because we can't divide by 0. So all of these important things, are we okay with all of those so far? Okay, so we're going to do an example applying those properties to a graph. So we're going to evaluate these limits. If I had given you at the beginning of class limit as x approaches negative 2 of f of x plus 5g of x, you would have had no clue how to begin that, because we've only done the limit from a single function on the graph. But our limit laws tell us we could rewrite this. We can do the limit as x approaches negative 2 of f of x plus, what could I do with the 5? So plus 5 times the limit as x approaches negative 2 of g of x. And this is kind of also the beginning of a long battle between me and those of you who don't like to show work. You have to write the limit. Okay, you cannot leave that off. So up until the point when we calculate a limit, we have to include that notation. Now, we can find these things. The limit as x approaches negative 2 of f of x. So I'm looking, f is my pink graph. As my x is approaching 2, where is our graph going to? That's g. So as x approaches 2, oh, negative 2, sorry. So as we're going to negative 2, on both sides, it is going to 1. Plus 5 times, okay, the limit is x approaches negative 2 of g of x. So now we're on the blue one. As we're approaching negative 2, what's that one going to? Negative 1. That's the point when I quit writing the limits. Once we calculate the limit, that symbol goes away. And so then we have 1 minus 5 or negative 4. B, how would I rewrite this one? what I need to do. We have the limit is x approaches 1 of f of x times the limit as x approaches 1 of g of x. Alright, so f, as we are approaching 1, what y value is f getting close to? Times, as x approaches 1, g is getting close to we're approaching 1, does not exist because we have two different values. We're trying to do the two-side limit. So if something does not exist, that means the entire problem does not exist. Last one, limit as x approaches 2 of f of x over g of x. So we separate those. So limit as x approaches 2 of f. So as x is getting closer to 2, what's f getting closer to? 1.5, maybe just slightly under that, maybe 1.4. It's not a perfect number. We kind of have to estimate it. G, as we're approaching 2, g is getting closer to 0. Can we divide by 0? So, undefined, does not exist. Alright, I'm going to just talk about the last few rules and then I'm done. Okay, we won't do any more examples today. So, the next things are the ones that are really, really helpful for us. If you have the limit of something to a power, so if I have the limit x approaches 2 of x squared, you can actually bring the limit inside. And get your limit and then square your answer. Okay, 7 and 8, these are really what will save us a tremendous amount of time. The limit of a constant is the constant. So if I said the limit as x approaches 3 of 4, it's just going to equal 4. And if you have the limit as x approaches a of x, we can just plug in. So like on this one, I could just plug in a 2. So this limit is equal to 2. Then we have 2 squared, which is 4. So we've kind of seen this. We saw sometimes we could plug things in and it gave us the value of the limit. Now we're kind of whittling down and getting to when that works. The last ones are just applying the exponents. So you can do the exponents of radicals just like a radical, or it's just like an exponent, so you can bring the limit underneath the radical. So Monday we're going to start using these to find limits without having to look at a graph or make the whole table.